Before we begin, always be sure to wear proper attire in the laboratory. Here's some examples of proper laboratory attire. And remember to always wear your goggles. Now let's begin. Before we use the spectrophotometer, we will prepare 5 cuvettes. 3 cuvettes will contain different concentrations of copper amine solution. 1 cuvette will contain the stock solution. This will be used to scan across all wavelengths. And another will contain deionized water, which will be your blank. Be sure to fill each cuvette so the bottom of the meniscus reaches the graduation line. Do not underfill or overfill your cuvettes. After your cuvettes are prepared, you may proceed to the spectrophotometer. Before inserting a cuvette into the spectrophotometer, you will always clean the sides with one of the chem wipes present in the lab. You will first insert your blank and zero the spectrophotometer. This is important because the spectrophotometer needs to be calibrated against the blank solution so that measurements after it can use the blank solution's absorbances as a zero reference. When inserting your cuvette, always ensure that the arrow in the cuvette is facing towards the light source. Next, after removing your blank, you will insert the cuvette filled with your stock solution and scan against all wavelengths. This is important because it allows us to find the most useful wavelength to scan our dilutions at. Additionally, it also indicates an approximate lambda max, a term that refers to the wavelength within a range of wavelengths where the absorbance is maximum. You will switch the spectrophotometer to quick reads. Before scanning your dilutions, you will use your blank to zero the spectrophotometer again. You may then scan each dilution. Be sure to always keep the spectrophotometer closed during the scan and when not in use. You will only open the spectrophotometer to insert and remove your cuvettes. Be sure to record your data in your lab notebook as well as any relevant calculations and graphs. Don't forget, to analyze your results, we will be using the Beer-Lambert law, which indicates a linear relationship between absorbance and concentration.